Hello everyone. Am I audible properly? Can anyone please tell whether I'm audible or not?
Yes, ma'am.
Okay. So let's wait for a few more minutes and start the session. Okay. I'm audible clearly, right, for everyone?
Yes, ma'am.
Okay. Yeah, thank you. So the first overview of the course is already covered, no? In the previous session. Are there any doubts for anyone? Yeah, I will discuss the summary of this week week one. So yeah, before that, if you have any doubts, please ask me. Any one of you, do you have any doubts from week one? Yeah, week one is mostly theoretical.
Yes, ma'am. Purpose of DBMS.
Yeah, purpose of DBMS. Yes, it's mostly theoretical, and I will cover the more important topics in this session. Okay. So
Ma'am,
week,
three
lecture.
different levels.
Sorry.
Three different level. View level,
Ah,
logical level, and physical
yeah,
level.
we'll explain that. Okay, I will explain that. Yeah. So yeah, lecture 1.1 is basically about this course overview that has already been covered, and I'm starting from lecture 1.2. So why do we need data management? Why do we need data management? Why we need to manage the data? Any answers? Okay.
For a transaction,
Yeah,
Ma'am, for
management of
audit purpose, for retrieval purpose.
yeah. So management of data is necessary because we need to store our data, and retrieval means we need to take the data, like whenever we want to know like something about our data, then we have to retrieve our data from the storage. Okay. And data management is important for transaction, for audit purpose and archival purpose. Okay. See, data management is important for individual, for small and big companies, and also as global. So data is like everywhere. Whatever we do, everything is kind of data, and the data has to be managed properly, right, for the proper use. So the storage, for the retrieval and transaction, everything. For all these purpose, we have to manage our data. So what are the two major approaches to store the data? The physical approach, and one is physical approach and the other is electronic approach. What does physical approach means? Physical approach means bookkeeping. Okay, physical data or records management are more formally known as bookkeeping. So the example here is, example I will explain with that example. So let us say we have a shop. Let us say we have a shop, and how the owner keeps the maintains the data, maintains their accounts. Basically, previously, how do they do? A book register. They used to maintain a register, and in this register they will note down all the things, like which customer has purchased what things, kind of thing. A book register was maintained on which the shop owner write the amount received from the customers and the amount due for any customer, inventory details, and so on. So basically, the shopkeeper or anyone owner, what he does, he will maintain a book. In that book, he will log everything, whoever customer has arrived and what he has purchased, his details and everything. He will note down. So the same thing. Okay, let us imagine the same scenario for large amount of data. Like if the, like let us imagine, like kind of, if the shop has many branches, and if the every single hour, like for every single hour, like many customers comes, then that kind of thing will take lot of time, right? Will take a lot of time. And what are the problems with this physical approach, physical storage? The problems with this storage of bookkeeping is like durability. So they are the physical this registers, whatever the things we are maintaining physically, they are prone to like physical damage. Kind of wear and tear will happen for the physical records whatever we maintain, and kind, yeah, because of the rodents they will spoil. And humidity, basically they are not permanent. Physical storage thing is not permanent. They are prone to wear and tear. So it is like less durable. And scalability, with respect to the scalability, very difficult to maintain for many years. Some shops have numerous registers spanning over the years. So if our data keeps on increasing, it is very difficult to maintain. We have to keep several registers. Okay, very difficult to maintain for many years. Some shops will have numerous registers spanning over the year. Security, they are not secure, no. Susceptibility, susceptible to tampering by outsiders. We cannot see, we cannot keep them secure. They are susceptible to tampering by outsiders. And for the retrieval, see, in order to see some record of a customer, we have to search through our registers and get the, and we have to scan through the entire our register and get the customer details. So it is very time consuming process to search for any entry. And coming to the consistency, as they are done manually, they are prone to human errors. Yes, please. Hello, anyone, any doubt? So not only for the small shops, but large organizations also used to maintain their transaction details in book registers previously. Okay, this is one approach of storing our data. Like physically, we store our data by keeping some registers. This is done manually. So the problems with this approach is they are less durable, and it is like scalability issues also. It is very difficult to maintain. if the if the data increases, then we have to keep many registers, and scalability will be will cause and will be difficult maintaining that, maintaining huge data and searching that data over the data will be very difficult. Security, they are not secure. For the kind of retrieval also, it is time consuming. We have to process the register manually, so it is time consuming. And consistency, as we are humans, it is prone, and humans are entering the data into the registers, it is prone to error. So it is not consistent as well. Okay, is it clear? Physical approach. And the other way of storing the data is electronic way. So it is much better than the physical data storage. Electronic data storage is better than physical data storage because they are durable, and scalability issue will be not that more, and somewhat secure. They can be password, but we can protect the data by keeping some password. And retrieval also, it will be less time consuming compared to the physical way, and it is easy to use. And consistency, it's also better compared to the physical storage. Efficiency is also better. And the cost also, see, in the case of registers, we need to maintain the books, but here just we will log the information in an Excel sheet. So yeah, one of the electronic way of storing the data is by using the spreadsheets. So spreadsheet softwares like Google Sheets, what are the due to the disadvantages of maintaining registers, organizations dealing with a huge amount of data shifted to using spreadsheet softwares for maintaining their records in files. Yeah, because of the disadvantages of the physical storage, we have shifted from physical storage to spreadsheet. They are durable, spreadsheets are durable as they are computer applications, hence the data is less prone to physical damage. Scalability easier to search, insert, and modify the records as compared to book ledgers, because it's easy, just we will search for something, we can search easily compared to physical storage. No need to span, no need to search each and every value, every log of your data. Just we can just search simply, and also inserting and modifying is also better compared to physical storage. Security also, it can be password protected, easy to use. Yeah, computer applications are used to search and manipulate the records in the spreadsheets, leading to reduction in the manpower needed to perform the routine computations. Consistency, they're not guaranteed because spreadsheets are less prone to mistakes than registers, as in the spreadsheets also data is entered manually. The consistency, 100% consistency is not guaranteed, but they are consistent compared to our physical storage. They're less prone to mistakes than physical storage. So it is mostly useful for single user or small enterprise applications. The kind of maintaining spreadsheets is mostly useful for single user kind of individuals. We can use the spreadsheets and log our data, or for small enterprise applications can use the spreadsheets. So why do we need to leave the file systems? Because lack of efficiency in meeting growing needs. Yeah, as our data, with the rapid scale up of data, there has been considerable increase in the time required to perform most operations. As the data is growing rapidly, there has been considerable increase in the time required to perform most operations. A typical spreadsheet file may have upper limit on the number of rows. So there is upper limit on the number of the rows, and ensuring consistency of data is big challenge. If we have a huge amount of data, the ensuring consistency of the data is also a challenge. Yeah, no means to check violations of the constraints in phase of concurrent processing. Yeah, we cannot check violations of constraints.
There is
Yeah,
background noise.
now is it there?
No, now it's fine, but someone like Mike was on, I think.
Sorry. Okay. Now is it fine now?
Yes, ma'am. Now it's fine.
Yeah, it's fine. Please continue.
Okay. Unable to give, and in the case of spreadsheets, we cannot be able to give different permissions to different people in centralized
Ma'am,
manner.
you will be giving week two summary, no?
Week one summary.
Okay. Thank you, ma'am.
Yeah. A system crash could be claustrophobic. So if the system crash has happened, then our data will be lost. And the security also, we cannot give some different kinds of permissions to different people in the case of spreadsheets. That's why we are moving from file systems to database management systems. There are more limitations because of these limitations. If the data scales up rapidly, then there will be increase in time to perform most operations, and there will be an upper limit in the number of rows, and consistency, maintaining consistent, ensuring consistency also will be challenge, and we cannot give different permissions to different kind of people. And if the system crash has happened, then it would be catastrophic. So history of DBMS is not that important. Okay, just these things are not that important, you can go. Yeah, yeah, only these things are important. What are the limitations of physical storage, and what are the limitations of file systems, and what are the advantages of database management system, we will see here. in the next lecture. Okay. Till now, you understood now, everyone. Lecture 1.2. History is not that important. Okay. Any doubts for anyone? Hello. No doubts, no? Okay.
No, ma'am.
Okay. So let us see a case study by using, like, by seeing the bank transaction. So in the bank transaction system, what consider a simple banking system where a person can open a new account, transfer fund to an existing account, and check the history of all her transaction till date. So just what is the example here? A simple banking system where a person can open an account, transfer fund to that existing account, check the history of all the transaction till date. The application performs the following checks. The application, whatever this application, will perform the following checks. If the account balance is not enough, it will not allow the fund transfer. If the account does not have the sufficient balance, it will not allow the fund transfer. If the account numbers are not correct, it will flash a message and terminate the transaction. If the transaction is successful, it prints a confirmation message. Okay. This is the example we are going to see. We will use this banking system transaction system to compare various features of file based implementation via database based implementation. So we will see this transaction management banking transaction system by using file based system and dbms system. So account details are basically are stored in accounts.csv for file-based system. So in the CSV file, we are storing the accounts information in case of file-based system. In the case of relational database implementation, just there will be tables. In the account table is in the account table we are storing the information of accounts. The transaction details are stored in ledger.csv file for file based implementation and ledger table for database implementation. Just for this transaction management, for this bank transaction system, we are using file based, and we are seeing that by using file based and database using dbms. In the dbms, basically we use tables. In the case of file based system, we are using here csv files. Okay. How in the case of python, in order to do any transaction, we first have to open the files to retrieve and store the transaction data. That thing, opening and everything, is handled by the dbms implicitly. No need to worry about the things if you are using database management system. Opening files and everything is taken care implicitly by dbms.
I have
But
a
in the case
question.
of python, yeah.
Actually, I was going through this lecture and I was seeing that for writing things in Python, you have to write a long way and SQL handle implicitly by DBMS. What do you mean to say? Like, how you mean to say the architecture of the software, the way it has been developed, you do not to worry about these things.
Yeah, open, see, we so in the case of database management system, in order to
Mm-hmm.
fetch any data, in order to do any transaction, like, we
Mm-hmm.
will just write the queries, we will query the database. So
Mm-hmm.
if we in order to update any details of your data, in order to update the details of your accounts or anything, we will use the queries only. So here we have accounts and we have what, like, logging. For logging, we are using ledger table. So
Mm-hmm.
yeah, we won't open any like, in order to, we won't open the accounts file directly. We are going to store the information, accounts information, in accounts table. Okay, there is something we know. Okay, in the case of dbms, I will just give me a minute. Okay, in the case of, my pen is confusing. Okay, my pen is not just okay. In the case of DBMS, tables are there. So there are two tables. One is account table. Okay,
Hmm.
another is some
Hmm.
ledger table. That is to maintain the record of our transaction. Okay,
Hmm.
here accounts table, this thing is for our understanding only. These tables are for our understanding, explicitly they won't present. Okay, our data will be stored somewhere in disk or something, in the some memory blocks data will be stored. This kind of opening this accounts file, kind of opening of the ledger file, that is handled implicitly by the database system. There are no like accounts file accounts.csv ledger.csv, that tables are not there. They are for our understanding only. Our data accounts information and ledger information is somewhere stored in the memory block, and we we won't worry about like how to fetch the data. That is handled implicitly by DBMS. So somewhere in the memory, this our somewhere in the memory these are stored, accounts information and ledger information is stored. We so no need to worry about opening this getting the information from the memory. Okay, this is handled by the database management system. In the case of Python, there are files, accounts file we have, ledger file we have. In order to do anything, in order to perform anything on our accounts or ledger table, in order to perform any operation on this files, on this data, we have to open this data, open these files. Not
Hmm.
to perform any operations on this data, on account data or ledger data, any transaction if we have to do, we have to open these files explicitly and write like do perform some operation on these files, on this data, and write it back to that files. This kind of thing like opening files and writing it back to the files, that is implicitly taken care by the DBMS. So somewhere in the memory the accounts information and this whatever the ledger information is stored. The fetching of the information from the physical disk is taken care by DBMS. But in the case of Python, we have to open the files, do some operation on these files, and then write it back the data, whatever the operations we have done, write it back the data to the files. That thing we have to do in the case of Python. So opening files, that kind of thing is implicitly uh, um, taken care by DBMS in the case of DBMS. But in case of Python, if we do handle the file system, then we have to do that explicitly. We have to open here accounts.csv in the writing mode we are opening, and so the same thing, and storing our data in some dictionary. For ledger also, we have to open those files and do some operation and write it back. That kind of thing will be there.
Acha,
Yeah, in case of
another thing, ma'am, I just want to ask about this SQL. That what is the basis of how this SQL DBMS software has been written? Basics of that. Maybe I agree that you will be teaching us how to use these SQL queries and commands. But
mm, mm.
on what platform this SQL has been developed? This architecture would have been developed, because this is nowhere talked about in the course also.
Um, this is query language, no?
Yeah.
It is, see, we just
Hmm.
what SQL does, it is a query language
Hmm.
by using which we can query the database. Okay,
Hmm. Hmm.
querying language means we can get the result, we can retrieve the data from the database, and we can update the data of the database by using this SQL.
Hmm.
This is just a language. It is like yeah, it is kind of developed by using relational algebra.
Hmm.
See, it is what it is, imperative kind of declarative kind of programming.
Hmm.
Here we don't mention each and every step. We'll just mention what we want and we will get this. So example, see here, select balance from accounts. That means we are selecting the balance from accounts table. That means we want to see the balance from the accounts table. This query will display the balance from the accounts table. It, see, in the case of other programming language, what we will do here, we will iterate for each row in the for each row in the accounts, we will fetch print accounts of balance. If accounts is a dictionary, then we will say accounts of balance kind of thing. We will iterate through each and every row of our table and finally display the thing. But here we'll just set what we are doing here is select balance from accounts. I want balance, just get that from the accounts table. We are not mentioning it step by step. We are just giving what we want and we are getting the output. That is declarative kind of programming. SQL is kind of declarative programming. It is very easy compared to other programming language. It is just query language. Okay.
How does database look like in actual?
Database. See, there are levels of abstraction. No, that when you see that levels of abstraction, then you will understand. I will explain that. Okay. So in the case of SQL, just you will write a query, just fetching the balance and see whether the balance is less than, like whether we have sufficient balance. If we have sufficient balance, then we will perform the transaction. If we don't have the sufficient balance, then we won't perform the transaction. That kind of logic writing we will do here also, but this is declarative kind of programming. But in the case of Python, we need to mention each and every step explicitly. Okay. And the writing back thing is not there. Here just we are performing the transactions and we can update the account things. That like here we use SQL, but here in the case of file system we use Python, but in the case of DBMS we use SQL, just for querying the database or for updating the database, like data of our database also we use the SQL. And writing back to the files is not there. Whenever we update the values using SQL, that will be updated in the database automatically. So implicitly that will happen. Writing back to the file is not there. So in the case of Python, we have to open our files in the write mode and just write whatever the updation we have to do. So you have seen, no? Now in the case of Python, what opening, closing of the files, that thing has to opening of the files, closing of the files, that thing we have to do explicitly, but that are handled by the database automatically. And these are the advantage. Now we will see the comparison between the file handling via Python and DBMS. So scalability with respect to amount of data. If the amount of data increases a lot, like if it has increased a lot, then it will be very difficult to handle insert, update, and querying of records. By if I use file system, then it will be very difficult to handle insert or update and querying the records. But in the case of DBMS, it is like easy. In inbuilt features to provide high scalability for large number of records. There are some inbuilt features to provide high scalability for large number of records. So because of this inbuilt feature, it will be easy to update or to query the records of the DBMS. The scalability with respect to the changes in structure. So if we wanted to change the structure of our file, let us say if we wanted to add some extra attribute, then if you use file system, then it will be difficult because so if you have added a new column, every column has to be like we have to write a value to that every row of that column. So it will be extremely difficult to change the structure of the records as in case of adding or removing the attributes. In the case of DBMS, adding or removing the attributes can be done seamlessly using simple SQL queries. But in the case of DBMS, adding or removing the attributes can be done very easily by using the SQL queries. There will be some insert update our the table, that kind of thing. We will use some queries and we'll just update the table, our table here. But in the case of Python or anything, if we use, then we have to add the data to each and every row of that extra column we have added. So that thing has to be done right by using some for loop or something. And we cannot use for loop also, no, because if the data is different for each and every row, if it is not the same thing, then we have to update that manually. That is kind of time consuming. So that is, yeah, DBMS will be better compared to file handling via Python. So time of execution, it will take seconds. In the case of Python, it will take seconds, but in the DBMS, it will take only milliseconds. Persistence. So data processed using temporary data structures have to be manually updated to the file. Here, whatever we do, that will be updated automatically. So data persistence is ensured by a automatic system induced mechanism. So whatever updation we do, that will be that will be updated automatically, that no need to do that manually. But in the case of Python, we have to write it back to the files, that has to be updated manually to the files. And coming to the robustness, ensuring robustness of the data has to be done manually. But in the case of DBMS, it has automatic backup, and recovery is also easy, and restoration needs minimal manual intervention. Okay, the restoration kind of mechanisms also we will see in the later lectures. But in the case of DBMS, there is automatic backup and recovery. Because of that, recovery and restoration of our database will be easy. So in the case, but
Excuse me, ma'am.
yeah.
Can you explain again the persistence part? I didn't get it.
So whatever operations we do, I have already told now here, whatever operations we do, that operations we have to write it back to the files. That thing has to be done manually in the case of file handling via Python. So, but in the case of DBMS, no need to do no, whatever updations we do, that we no need to write it back to the data database. That will be taken care automatically. In the case of Python, if we update some account information in the account table, if there is some let us say there is one account file, and in that file you are updating some account information. Okay, you are updating some account information, his name or something you are changing. Okay, and in the case of Python, we'll do that. We will just open this file and get his record and update this information. And what you have to do, you have to write back this information to the file again. You have opened the file in the read mode and done some operation. After performing the operation, the file has to be updated. So the file has to be written back. But in the case of DBMS, you have this accounts table. The account, whatever the updation you do, that will be updated in the database automatically. No need to write that information uh, back to the file. The kind of file thing is not there. No, here no, we are not worrying about our about writing back to the file or opening the file in the case of DBMS. So maintain, because of this, the data processed, whatever data processed, using temporary data structure, we whatever the operations we do, for that operations we use the temporary data structures. No, have to be manually updated back to the file. Whatever operations we do, that has to be manually updated back to the file in the case of file system via file handling via Python. But in the case of DBMS, whatever we do, that will be updated in the database automatically. So data persistence is ensured by a automatic system induced mechanism. Now clear, or some
So, ma'am, PostgreSQL or MySQL is database and data and DBMS.
MySQL or whatever that is, like, see, SQL is a query language by using which you can query the database.
No, no, PostgreSQL that we have
Ah,
downloaded like software.
yeah, that will, in that you can store the database. That is database management system. That is database management software. Okay, where you can store your data, there will be database. You can create your own database and query that database, update the database, whatever thing you can do. You can do.
And
Okay.
what is the common in all these kind of software? Like they use relational database management system, right?
Mm. Yeah, there are relational database management systems. There are non-relational database management systems also for the non-relational database thing. So whatever the thing in the relational database, the implementations can be different in the different softwares you are seeing. Okay, coming to the robustness, whatever ensuring the robustness of our data has to be done manually, but there will be automatic backup and because of that, recovery of the database will be easy in the case of DBMS. So how this backup and everything is done will be done, that will be we will see in the coming weeks also. Kind of in the case of file handling via Python, security is difficult to implement by using Python. But in the case of this DBMS, uses specific access at DBM database level. So if kind of bank transaction example only, there will be, so for manager, this access can be different. For the manager, access can be different, and for the user, we will see kind of some particular kind of details. Like we will see our account information, what are the transaction we perform on, that things we will see. But in the case of manager, he will see all the information of that particular branch, all the accounts information, all the employees information also the manager will be able to see. In the case of employees of that bank, like what they will see, he will the employee will be able to see all the customers information, and he can able to update the information of the accounts of the customers also. Like we can debit amount from one account and credit to other account, the employee can do that kind of specific access level can be can be provided by using database. But in the if you use file system, that will be difficult to implement it by using Python. Programmers productivity, coming to programmers productivity, which one is easy? SQL will be easy, no, because handling of files, that will be automatically taken care by DBMS. Just we need to write the correct query not to fetch the data, and we need to perform some correct update operations in order to update our data. So as most file operations involve extensive coding, just mute. Everyone, could you please mute? Okay, coming to programmers productivity point, if we file handling via Python, if we use file handling via Python, most file access operations involve extensive coding to ensure persistence, robustness, and security of the data. So the file handling thing we have to do using the Python. That will take coding. But in the case of DBMS, there are standard and simple built-in queries, reduce the effort involved in coding, thereby increasing the programmer's throughput. Okay, just file handling thing we no need to do. Opening, closing files, writing back to the files, reading, that kind of thing. No need to worry. So that is automatically taken care. Just we need to worry about operations. What operations we have to perform to the database. So it will increase the programmer's productivity. And coming to the arithmetic operations, easy to perform arithmetic computation. In the case of file handling via Python, it will be easy to perform the complex computations. But in the case of SQL is basically for querying the database. We can just we can perform the operations, but the complex operations we cannot perform. Just the limited set of arithmetic operations are available in the SQL. But if you wanted to perform some complex operations on the database, then we won't. Then SQL cannot be used. So basically, what in the industries they will do is like they will just use the SQL for querying the database, for getting the data, and whatever the data we get, if you wanted to perform any operation, some complex operation, that operation will be performed using the Python. And after performing that, then we will update the information in the database by using SQL kind of thing. Okay. Understood now this point? Coming to cost, low cost for hardware, software, and human resources. So it is kind of cheap compared to DBMS. The kind of database management system, it is high cost for hardware, software, and human resources, because database administrators have to be present, and he will take care of the data, whatever the data that has to be entered. For maintaining the data, database administrators has to be will be there. And yeah, there will be kind of it will be kind of high cost also for hardware, because the hardware is different. There will be, and software is also different. It will be high cost compared to file system. Is it clear these points?
So file system is managed by the operating system only, or have any other software?
No, file system is operated by operating system only. So file system we can do that manually, or using Python also we can do. So manually, if in the case of Excel sheet, whatever Excel sheet we can do that manually, or you can use Python also to manipulate the data of that Excel sheet. Just open that file and do some operation and write it back to the file by using the Python. Okay, you can do the things manually also, but it is time consuming. Okay, you understood all these points, no? Everyone, is there any doubt in these points? Anyone of you? If you have anything, please ask. Okay.
Understood, ma'am.
Okay. The same thing here. The same thing, whatever points we have discussed, the same thing, just I will read out it. File handling via Python, if the number of records comparison between DBMS and file handling via Python, as the number of records increases, the efficiency of the flight file reduces. The time spent in searching for the right records will be increased. The limitations of the OS in handling the huge file, because of the limitations of the handling of the OS in handling the huge file. As the number of records increases, in the case of database, databases are built to efficiently scale up when the number of records increases drastically. Inbuilt mechanism like indexing for quick access of the indexing and everything you will see in the database. There are some inbuilt mechanism like indexing for quick access of the right data. If the data is increased, searching through that file will be difficult if you use file handling via Python. But in the case of DBMS, there is some inbuilt mechanism like indexing. So structural change, in order to change any attribute, to add an attribute or initializing the new attribute of each record with the default value has to be done by a program. It is very difficult to detect and maintain relationship between entities if and when an attribute has to be removed. Okay, if we need to change the structure of the of our file, let us say if we need to add new column, then we have to add data to each and every row of the new column via code. But in the case of DBMS, during adding an attribute, a default value can be defined that holds for all existing records. The new attribute get initialized with the default value. During deletion, the constraints are used either not to allow the removal or ensure its safe removal. Okay, if some column has to be removed from our file, but if the column has some association with the other column, like if you say for other column we are just doing, okay, if we have column 1 and column 2, and column 1 is nothing but column 2 is nothing but column 1 plus 2, something like that, some data. So column 2 is associated with column 1, but if you have to remove this column 1, when we use the file handling via Python, that will be difficult. It is very difficult to detect and maintain relationship between entities. It is very difficult to maintain this. And if when an attribute has to be removed, then it come like if column 1 has removed, then how this column 2 will be computed, that will be kind of very difficult to maintain in the case of file handling via Python. But in the case of DBMS, during deletion, constraints are used either not to allow the removal or ensure its safe removal. There will be constraint checking that will allow that will allow the safe removal of that column. Okay. Coming to time and efficiency, the effort needed to implement a file handler is quite less in Python. In order to process 1 GB file, the program in the Python would typically take few seconds. The effort to install and configure a database in DB servers is expensive and time consuming. In order to install and configure a DB in a DB server is expensive and time consuming. And but in order to process 1 GB file using SQL query, it will take only few milliseconds. Querying it won't take much time. But in order to install, in order to set up the database, it is time consuming and it is expensive. Okay, only for the initial setup it is time consuming and expensive. Once it has set up, then the querying we can do in few milliseconds in the case of Python, but the file has to be opened every time and it will take few seconds. If the number of records is very small, the overhead in installing and configuring database will be much more than time advantage obtained from the executing the queries. So if you are if whatever the data which we are going to maintain is very small, if the number of records is small, then it is better to use file system compared to database, because in order to install the database and maintain that, that is expensive and time consuming. That's why. However, if the number of records is really large, if the records are large, then time required in the initialization process of the database will be negligible as compared to time saved in using the SQL queries. So it depends. If your data is huge, then it is better to use database. But if you have very small data and small, if the data is small and we do the minimal interventions to the data, then it will be better to use file systems. There is kind of this drawback, like initialization setup will take time and it is expensive for database. The file system, the Python, coming to these points: persistence, robustness, and security. Data process using in-memory data structures stay in memory during processing. After updates, these are manually updated to the file on the disk. So first we will bring our data to the memory by you, and whatever the data we bring, that will be stored in the data structures. We perform the operation on the data structure, and whatever data structures and whatever operations we perform on the data structures, that has to be written back to the memory, that has to be written back to the file. That things are done manually. But in the case of DBMS, data persistence is ensured via automatic system mechanisms. The programmer does not have to worry about data getting lost due to manual errors. Robustness, ensuring consistency, reliability, and sanity is manually. Whatever things we do, that everything is manual. So yeah, via multiple checks. Whatever we do, we have to, in order to make our file database robust. In order to make our data robust, we have to do the multiple checks, as we are doing everything manually in case of file handling via Python. On a system crash, a transaction may cause inconsistency or loss of data. If system crash has happened in between, then there will be inconsistency of our data. But in the case of DBMS, there is automatic backup, recovery, and restoration that will take minimum time, minimal manual intervention. The backup and recovery plan can be devised for automation recovery on the crash. So there is automatic backup and recovery for recovering our data of the database also. It will need some minimal manual intervention. Security is difficult, that we have already seen, and maintenance, everything that is done manually, so it can be prone to human errors. So, but in the case of maintenance of the DBMS, has inbuilt mechanism to ensure consistency and sanity of the data being inserted, updated, or deleted. The programmer doesn't need to do such checks. But configuration, that means initial configuration of the database, takes times. The installation and configuration of the database is specialized job of database administrator. A programmer, on the other hand, is saved the trouble. Okay, whatever the configuration of the database, that is taken care by the database administrator. Programmer just query the database. Handling huge data, as data grows beyond the capacity of the file handler, more efforts are needed. But database management system can handle even terabytes of data. Programmer does not have to worry. So it is a programmer no need to worry about the handling of the data. So, but in the case of Python, it provides extensive support for arithmetic and logic operations. But in the case of DBS, we have limited support for arithmetic and logical operations. Coming to cost, file systems are cheaper to install and use. No specialized hardware, software, or personnel are required to maintain file systems. No specialized personnel are required to maintain hardware and software things in the case of file system. But in the case of DBMS, large databases are served by dedicated database servers, need large storage and processing power. Need large storage and processing power. Database management systems are expensive software that have to be installed and regularly updated. And databases are inherently complex and need specialized people to work on it, like DBA, database administrator. The above factors lead huge cost in implementing and maintaining database management system, because we need specific hardware and software requirements, and not to maintain that there should be some database administrator. But if you use simple files, just no specific hardware, nothing is required. and you can do that. It is, you can do, we ourselves can do that, but here we need specialized database servers and someone to install that and to maintain that database administrator is required, so it is costly. Okay. So if we have large amount of data and the data is getting updated every time, like most, like every day, each and every day, then it is better to use DBMS. Only initial setup will take time. Later, just the programmers just need to worry about querying the database and updating the databases. That's all. But if you have less data, small data, and do just kind of less updation to the database, then we can use the file systems. Understood, no, everyone? Clear?
Yes, ma'am.
Okay. In this module, we'll study the levels of abstraction of the database. So there are three levels of abstraction: physical level, logical level, and view level. So physical level describes how a record, for example, here instructor is stored. So yeah, in the kind of physical level, it describes how the data is stored in the database. So are we going to store the data in in arrays or in hash table or in any data structure are we going to store? That thing is taken care by the physical level. In the physical level, it describes how our data is stored. Okay. Logical level describes what data we are going to store in the database. Logical level describes data stored in the database and relationships among the data fields. Okay, let us say the same example, bank information. Then what all information we have to store in the database? We have to store customer details, employee details, manager details, account details, everything. So yeah, what all tables we can be stored? What all tables can be stored in the database? Accounts and the employees details and customer details, all these three tables. For accounts, one table; for customer, one table; and for employees, there can be other table. Let us say in the case of what education, a university, then we have to maintain student information, faculty information, and also what other information we have to store in the case of university? Some enrollments information, courses information,
About
all this
courses and subject.
yeah, yeah, courses, enrollments, students, and marks, grades, everything. So all these things. Logical level describes what we are going to store in the database, whereas physical level describes how we are going to store the information in the database. Okay, are we going to store the information in arrays or hash table, or there are some other data structures also like B trees, B plus trees, that we will see later. Yeah, which data structure, in which data structure, or in which hard, in which storage, in which file we have to store our data, that will be decided in the physical level. This that will be described in the physical level. So view level describes like what is visible to the application. So application programs hide the details of database. Views can hide information such as employee salary for security purpose. So in the case of bank, for customer, what we will see, we'll see only our account information, our account name, account number, and the bank name, bank IFC code, and everything. Only that kind of information, only that account information. The kind of employees, the employees of the bank will see all the customers information, all the accounts information. Like as the employee has to perform the kind of what debiting and crediting of the amount from one account to other accounts, he will be able to see all the customer informations of that bank. Whereas manager will see all the informations of the accounts of the particular branch. Branch manager will see all that. So kind of whatever the things the users are going to see is different. So there will be kind of different views for different users. Okay, but the database is same. The single database can provide different views to different users. This is a simple example what architecture of the database. You have physical level, lowest level that describes how to store the data. Logical level describes what we are going to store in the database, what information, accounts, the instructor, that kind of information. What information has to be stored, actually stored in the database, that kind of thing is described in the logical level. View level shows whatever the required things to the users. Okay.
Ma'am, in logical level, is it a schema that is being stored?
Logical level just describes us what we are going to store in the database. Yeah, schema only.
Okay.
Excuse me, ma'am.
Yes, please. Yeah,
Hello.
yes. Yeah, yes.
I wanted to ask about physical level. So
Yeah.
basically, the physical level defines the data being stored in the form that how many bits we are assigning and about its storage properties, right?
Mm. Yes, in the storage property, it tells us how we are going to store. Yeah, storage thing only. Memory
Oh,
blocks and everything, it will, yeah.
okay, all right. And the different view levels define the like, for example, there are many people using the database, so all of them will have different access to different kinds of data. So, say view one is like the view of the data admin, so he can view everything in the data. And
Yes,
view
yeah.
two is for someone who only checks the account income, so he can only see the income data. That's how it is.
Yes,
It is.
yes,
Okay.
yeah, yeah.
All right. All right. Thank you.
So schema is nothing but what uh, it is analogous to the variable and value of the variable in case of programming. In the case of programming, we just use the variables. No, it is similar to that. The schema. Logical schema is describes the overall structure of the database, analogous to the type information of the variable in a program. Example: the database consists of information about the set of customers and accounts in a bank and the relationship between them. So, in the case of customer schema, what a customer will have: name, customer ID, account number, Aadhaar number, mobile number. So, that is described in the logical schema or logical level. Account schema that describes in the account schema account number, account type, interest rate, minimum balance, all these things are present in the account schema. Account schema is nothing but account table here. Okay, so what things are there and what are we are going to store in the database, that is described in the logical level. So overall logical structure of the database is described in the logical schema. Okay, what tables are we going to store in the database and what are the attributes going to be present in that tables of the database. So for the customer table, we'll see name, account ID, customer ID, account number, all these things. For account table, these are the attributes that is described in the logical schema. So in the case of physical schema, that describes the overall physical structure of the database. It describes the physical structure, how the records are stored in the database, the physical structure of the database it describes. So instance is nothing but the actual content of the database at a particular point in time. So analogous to the value of a variable. So yeah, instance is nothing but the actual content of the database at a particular point of time. This is the example of an instance, customer instance and account instance. What are the values of the table at that particular instance? And what is physical data independence? It is the ability to modify the physical schema without changing the logical schema. So just okay, previously, like let us say, first we have stored our data in arrays. Later for the convenience, later for the easy searching of our data, we have moved from, let us say we have moved from arrays to some other data structure. That even if we change the way we store the data in the database, it should not affect the logical level. So we are going to store the accounts customer information only, but previously we stored the information in some different data structure. Later if we move to the some other data structure for better querying, for better retrieval of our data, then that should not affect the logical schema. So whatever changes we do, that should not affect the logical schema. The ability to modify the physical schema without changing the logical schema is called physical data independence. Okay. So there is something called logical database independence or logical level independence also, data independence also. The ability to modify the logical schema without changing the view, then that is called logical data independence. Whatever changes we perform in the logical schema, that should not affect the view level. That is called logical data independence. And there are different data models. These are not that important. Okay. Relational model, here in the relational model we'll store our data in the database, in the tables. Yeah, DML means DDLL means data definition language. So it just defines the data, like specific notation for defining the database schema. It is notation for defining the database schema. It just defines how to create, like the database schema. That means that in the instructor table, here let us see the example. This is example for DDL command. So here just we are creating the table instructor, the instructor, yeah, this kind of things you will see in the week 2 and week 3, just creating the table, and these are the attributes of the table: ID, name, department name, and salary. And ID, what is the type of ID? It is character, and name is varchar, department name is varchar, salary. So DDL is defines the notion of the database schema. DDL compiler generates a set of tables, templates stored in the data dictionary. DDL just defines the database. Data dictionary contains the metadata. Okay, this thing and integrity constant, all these things we'll see when you use SQL. So DML is nothing but manipulating the data of the database. Language for accessing and manipulating the data organized in the appropriate data model. This is called DML, is also known as query language. So SQL is both DDL and DML. By using SQL, we can just create the table, and we can query the tables also. SQL is both DDL and DML. DDL means defining the database, and DML is nothing but manipulating or accessing the data of the database. So there are two different classic languages for querying the database. Pure used for properties, for computational relational algebra. In the case of relational algebra, this is pure query language, and there are other query languages also, like tuple relational calculus and domain relational calculus. Mostly we'll see about the relational algebra in this course. And SQL is also is used mostly for as commercial language. Okay, that is for querying the database. So database design, we will see in the coming lectures also, how to about the physical design, logical design, we will see in the coming lectures. Logical design, deciding on the database schema, that will describe what are we going to store in the database. That things we will see in the coming lectures also. Yeah, that's all about this lecture. Just here what we have seen, mostly physical level independence, physical level, logical level, and view level. And physical data independence, logical data independence, what is physical schema, logical schema, what is instance, that things. And data model, that things, just relational model only we are going to focus in this course. Relational model is nothing but we're storing the data in tables, just tables. Whatever the information we are going to store, that we do in the tables. DDL and DML is nothing but DDL is data definition language, DML is manipulation language, by which DDL defines a database, and DML just manipulates, is used for manipulating and querying the database. Mostly these are the different kind of querying language, querying languages: relational algebra, tuple relational calculus, and domain relational calculus, and SQL. Okay, that's all in this lecture. Important things. Yeah, any doubt from this? Anyone? Anyone? Any doubt?
Hello, excuse me, ma'am. Am I audible?
Yeah, yes.
Good evening, ma'am. I just had a doubt in the schema part that you were
Mm.
mentioning or you explaining. In
Mm.
the physical schema, you mentioned that it should not affect the logical schema, right? Then it's
Yes.
logical
Mm.
data depend independence. But
Yes.
and in the logical data independence, you mentioned that it should not affect the view level
Mm.
or view data or
Mm.
view schema, right?
Yeah.
So why not also include the logical or the physical data
See
for
the
the
see
logical
whatever.
independence?
See, you can see this diagram. Physical, see, view level is dependent on logical level. Logical level is dependent on, oh, sorry, the other way. Here, whatever we are going to store in the physical level, only that thing that will be there in the logical level, right? So logical level, whatever we are going to store in the physical level, that things only will be present in the logical level, right? And view level also, for the view level also, whatever that is there in the logical level, that we are going to see in the view level. So the kind of dependence is from physical level to logical level and logical level to view level. The dependence is like this, in this way. The logical level is dependent on physical level and view level is dependent on logical level. So if you change something in the logical level, that will be that will
Basically, ma'am, that should not impact the view level, you said, na? But
yeah, that should not impact the view level. Yeah.
my query was why should not it no, why should it not also impact the physical level also? Because view level is between the physical and the view level and the logical level.
Yeah, the physical level also it won't impact if you change something in the view level. The physical level, okay, the physical level will be impacted because if you create new table, then we have to store that information in the physical level also, right?
Ma'am, but in case we have stored the data in arrays and I do something to the logical level, it will also be stored in the array, no?
Yeah, it will, that kind of things. Yeah, sometimes, see, if you have decided like, in the case of university kind of thing, uh, kind of schema, in the case of university database, you have decided to maintain the history of only, to maintain the data of, to store the data of students, instructors and faculty, and yeah, some details. But if you forgot to store the data of enrollment, if you just in the logical schema, logical level, you decided to store only few tables, like only this tables, instructor table, students table, and course information, but you forgot to mention enrollments, but later you thought enrollments should be there, then enrollments table should be stored in the physical level also, right? In the physical level also, that will be stored, should be stored in the physical level also. But the data structure which we are going to use, that thing also, you may decide like that, you may change the data structure also. Okay, instructor, the enrollments, if you decide to store in some kind of dictionary, then, but in the other tables like instructor, student, and course, you just decided to store them in arrays, but in the enrollment, you decided to store in dictionary. So whatever the changes you do, that will be affected in physical level also sometimes. But if you change, like sometimes, if you just if you just decided to store some additional table, then the additional table should be stored in the physical level also. Okay, but whatever that has already there, that won't be affected. But whatever newly you are going to store in the physical level, only that thing will be affected in the data, in the physical level. But it won't affect the user, it won't affect the user. Whatever the user is going to see, that will be same for the user. Okay.
So, ma'am, change in physical level may not affect logical level, right?
The change in physical level should not affect the logical level. So just the physical level describes how we are going to store, just it describes how the data is stored, but what you are going to store, that is decided in the logical level. Even if you are arrays or any other data structure, just you are going to store only this information. If you change any data, anything in the physical level, that should not affect the logical level, right? If you just switch from one data structure to other data structure, the logical level should not be affected.
And change in logical level may affect both, like view and physical.
The change in logical level should not affect the view level. That is logical data independence.
But if I remove some attributes, then in view level it can change now.
Yeah, in the view level it can change, but that is not that. See, it can change, but if but what is logical data independence is nothing but if you change the view logical level, it should not affect the view level. If you change something in the logical level, some other factor, then the view, you can create different view. You can get the different view. Whatever the views existing are there, that also. See,
I
if you
think for
try to
changing
add
things,
some.
we can change entirely. Like if we can change things that are interconnected to each other, they will affect each other. But we have to follow some kind of protocol that is industry selective. So, just like ma'am said, that we have the rule that the change in logical level should not affect the view level. So that, yeah, of course, it can change the view level. It can affect the view level also, but it should not, because that is not very advisable.
Yes, that's what my query was. Now, if we're talking about logical level, then it should not impact both physical and as well as view level. Na? But in the definition itself says that the logical data independence is, it only talks about and includes the view level independence. Like it should not impact the view level. Why not physical level? That's what my query is.
Uh, I think it is because the given statement that physical level only defines how you are storing the data, not why. Why is answered in the logical level.
Physical level is
What is
just
answered
about
in the
the
logical?
data structure used to store the data, but the data content is same only now.
Yeah, exactly. The contents that you are using to use your logical expressions on, they're only going to stay the same. You can change the logical expressions that you want to use on the data.
Okay, I hope that is clear.
Excuse me, ma'am.
Yes, please.
I have a doubt in DDL and DML
Mm.
language.
Okay. Yeah, yes.
Can you explain it again? What the DDL is? I understood DML little bit, but you said it is something which
For
creates.
defining the, yeah. So DTL is used for creation of tables. So in order to creation of the tables in our database. So let us
Mhm.
say if you wanted to create the instructor table, then for instructor you will just you will use this command, create table instructor, and mention ID, name, this is column name as attribute, and department name, these are attributes, these are column names, and salary, these are column names. So,
Mhm.
and it describes the data type also of this ID. ID is character, and the name is a string, variable character, variable and character. Department name is also a string. Salary is numeric, like numeric data. So DTL defines the database schema. So for the in the DTL, we are defining the table and the structure of the table. Okay, that is DDL. DDL is nothing but we are defining the database schema. Like what we are creating instructor table. Similarly, we can create another table and define what are its attributes. Basically, it is used for defining the tables in our database. So it is specification notation for defining the database schema. So
Defining
just,
and creating both, or just defining, like
yeah, defining is, yeah, just creating or define, yeah, both are same. You can think as defining and creating. That is done using DDL. Okay.
uh, okay. So what do we do with DML?
DML is for querying the tables. So whatever the tables that are present in the database, we can query by using DML commands. Like we can fetch the data. Like you can say select ID from instructor. That will fetch all the IDs of the instructor. Select name from instructor. That will fetch the names of all instructor. So if you want some specific instructor only, then you can specific instructor from some specific department. You can say select name uh, from instructor where department name is something computer science or something. You can that kind of
Okay.
querying you can do by using DML. DML is for querying the databases. Okay.
So
And
DDL is
manipulating.
like, sorry, DDL is like creating a data, and DML is like upon that data we do some calculation or some query things.
Manipulation, yeah. You can do
Okay.
some manipulating or accessing the data.
We
That
can
is
manipulate the data using DML or DDL itself because
you can manipulate, yeah. You can manipulate the data using DML. Like you can just update the name, the kind of thing you can do using, or you can just increase the salary or something you can do using DML. Okay,
okay, but for the attributes of that table we will use DDL.
yeah. For defining the attributes, we use the
Ma'am, what
DDL.
is data dictionary referring here?
DDL compiler generates a set of table templates stored in data dictionary. So data dictionary is nothing but that will has the information of your table. So let's say metadata. Data dictionary contains metadata, that is data about data. So here uh, okay, you have database. In the database there will be different kind of tables. Instructor table, in the instructor table there is kind of ID, name, salary. So the ID, department name, salary, that is the metadata. So data dictionary is nothing but data about data. So in the instructor table these are the things you are going to store. In the database there is instructor table and some student table and the other tables also, instructor table and courses table, enrollment table. In the courses table what are attributes are there. So that is the data about data. That is called data dictionary. It contains data
Information about
dictionary.
data, right?
Yeah, that is metadata.
Ma'am, if we have to add an additional attribute after we have already defined the basic schema, so would that thing come under DDL or DML?
And that will come in DDL only. As we are defining the structure of the database, that will come in DDL only. Because we
Oh,
perform some, if you are adding new attribute, that means you are changing the database schema,
structure of the
right?
schema.
Structure.
Yeah,
So that
okay.
will, yeah,
Thank you.
yeah. Okay, any other
And
doubts?
updating the value in the same will be DML, right?
Updating some values will be in the DML. If you are changing the structure of the database, then that is DDL. Okay. Yeah, coming to lecture 1.5. So logical design and physical design that you will see extensively in week 4 and week 5. So what tables you have to store in the database, that is logical design, no? So deciding on database schema, that means what tables should be stored in the database and what is the relationship between the tables, that is the logical schema. And deciding on that database schema, that comes in the logical design. Database design requires that we find a good collection of relation schema. So that is a business decision. What attribute should be recorded in the database? That is like business decision. So computer science decision is what relation schema should we have, and how should the attributes be distributed among the various relation schema. So what are we going to store in our relation schema? What are we going to store in the database, and what are the relationship between the attributes? So logical design in the logical design will decide what are we going to store in the database, what tables should we actually store, and in the tables what information is relevant for our business purpose, or yeah, what information is actually needed in order to fetch in order to do some manipulation or something. That kind of things will become under logical design. And deciding on the physical layout of the database, in which data structure or where we have to store, which is better, which data structure is better, or yeah, that things will come under the physical design, deciding on the physical layout of the database.
Can you
So
make the logical design part once again?
So logical design, in the logical design will decide. So let us say if you wanted to implement, if you wanted to store, um, what is, if you wanted to store the information. So we have seen already the bank and the university example. No, the other example.
We can
Say,
have railway example.
okay. If you wanted to maintain railway information, railway system, railway management system, if you wanted to store that in a database, then what information actually you have to store in the database? That thing will come in the logical design. So in the railway management system, what thing we have to store in the database? What all things you can think of in the railway
I
system?
think
Train
number
number,
of train number, number of seats, number of tickets, things like these.
Yeah, trains,
train
about
name,
trains,
So
trains about, yeah, this is one set. For the trains, there will be one table, and the other table,
stations.
stations. For the stations, there is one table, and the other table, and
Employee or staff like that.
yeah, employees, staff, and for train ticket booking also, for booking purpose also.
So these all are tables, right?
Yeah, these all are tables. What information, which tables actually we have to store in the database, that is logical design. Now we have thought of the trains, stations, registrations, like booking, and kind of what other information, staff, and other things. All these things will store in the that what tables actually we are going to store, that will come in the logical design. In that table itself, what all attributes we have to store. For the train, we have to store train number and the list of the stations visits and the time it visit, the time it will visit that particular station. All these things that will come in the logical design. What is the relevant information for us? That thing, what all things we have to store in the database, that will come in the logical design. And how it is stored and in which data structure we are going to store, that will come in the physical design. Okay, so logical design, that will see in the week 4, that we will see discuss about the year diagrams and everything at that time. And there is kind of normalization techniques also in order to avoid the redundancy of the database. So here you can see in this. Okay, what is this relation? This is, let us say, instructor table here. Okay, here it has id, name, salary, department name, building, budget. And here, is there any redundancy? For the instructor, only ID, name, salary, and department name is relevant. So building budget is relevant for an instructor, not relevant, no? So this can be broken into two tables. One is instructor table and other is department table. For the instructor, we can maintain ID, name, department name, salary. For the department, there can be another table, department name, building, and budget. So this kind of things will come in the logical design only. So what are we going to store in the table, and what tables we are going to store in the database, and optimization, the normalization of the tables, all these kinds of things that will come in the logical design. Okay, in order to avoid the data redundancy, there are some normalization techniques. So that things also will come under the logical design. So here you can see the department name and department name is present in both tables. This is kind of redundant, but it is relevant. Okay, so kind of this, all these things we'll see in the logical design. Well, we are seeing the week 4 and week 5. Okay, so here two ways. This will see in week 4 here diagram, and normalization week 5. That things we'll see. So object relational model we are not going to study actually. Just we'll see relational models only. What is the disadvantage of the relational model? Flat and atomic values. The relational model will store our data in only tables. But if our data cannot be stored in tables in a tabular manner, then there is something called object relational data models, that we are not going to see in the course. Just this is just an introduction kind of thing. We can extend the relational data model by including object orientation and constructs to deal with the added data types. So instead of storing the tables, we can just store the objects in the relational data models. Okay, in the relational models, we have tables and the values of the tables are atomic. So here you can store only single values, no? But in the case of object relational data model, you can store objects in the tables. Allow attributes of the tuples to have complex types, including non-atomic values such as nested relations. Okay. preserve relational foundations, in particular the declarative access to data while extending the modular power. What is the advantage? As we are storing the data in table, but so the accessing kind of thing is same as it is a table, and you can store, instead of atomic values we can store the what complex nested relations also. Provide upward compatibility with existing relational language. As we are going to store the data in relational like tables, it is compatible with relational languages also. Yeah, this object relational data models we are not seeing in this course, just relational data models only. All these things also XML, this also we are not going to see.
So in this course, only on a structured data, not on non-structured.
Only RDMS we are going to, relational database only we are seeing in this course. Yeah, now this is database engine. Our date in the database engine, there are three components. All things, whatever the things we do, that is done using the database engine. The database management system uses database engine. In the database engine, there are three components. One is storage manager, and the another is query processing, and the other one is transaction manager. What storage manager does? Storage management, by the name itself indicates, it manages the storage. So storage manager is a program module that provides the interface between low level data stored in the database and the application programs and queries submitted to the system. So our data is actually stored in somewhere in the disk. So it provides, the storage manager provides the interface between the low level data which is stored in the database to the application programs and queries. Okay, it is just kind of interface through which we can interact to our data. Storage manager is responsible for the following tasks: interaction with the OS file manager, efficient storing, retrieving, and updating of the data. So it is kind of interface that enables the efficient storage, retrieving, and updating of the data. It deals with storage access and file organization, indexing, and hashing. Okay. So these things in detail we are not going to see. This we are seeing what storage manager does. Our data is somewhere in the physical disk. From that physical disk, how we are able to retrieve our data with the help of storage manager that provides the interface between the low level data which is stored in the database to the application programs and query, whatever the queries we are submitted, based on that only we will receive the data, no? So it is kind of interface between the data which is stored in the physical disk to whatever we are going to see. It interacts with the OS file manager, and it enables efficient storing, retrieving, and updating of the data. What query processing does? Query processing does parsing and translation. So what parser and translator does? It will just checks the query for the syntactical error. If there is some syntactical errors, it reports. It reports that our query has syntax. The parser and translator does that. And whatever the query we write, that will be rewritten. That will be rewritten. So if there are something, some operation, some inner sub query, that will be converted to joins kind of thing. That we will see in the week 2 and week 3. Like we will just perform joins and do sub query, inner query also. Our query, whatever query we write, that will be rewritten, and that will our query processor. What it does, it will come up with the most optimized query. Okay, the query you write, that will be rewritten, to optimize it. And yeah, it will, the optimized query will be executed by using the it will first generate the execution plan. What it will generate, it will say, okay, let us see, suppose we have an SQL query. Okay, something, select some name from instructor, comma something, some join you are performing, comma some with other table you are performing, course where course equal to something, some other course name you are saying, computer science. Okay, so what this query processor will do, it will just check whether our query has some error, any syntax error. If it has some syntax error, if we don't use here some kind of string like single quote, then it will report us. The query parsing and translator does that. It will report that it has some error in the query and it won't execute. Okay, if the query is corrected, if we give the correct query, then the parser will just check for syntactical errors, and then the query will be return, like it will write all the possible ways of fetching our data. You want the instructor who just teaches this computer science course, the query will be like okay, this information we need, and the query optimizer will find the better way to retrieve our data. So query will be rewritten in order to efficiently retrieve the data. So optimizer will optimize our query and it will generate execution plan. Here this one is like instructor and course we are joining by just saying comma cross join. This is cross join. So it will just rewrite our query how to execute this query. First we will perform the joining of this table and then filtering of this table or we need to perform, or it will just check whether we will perform the filtering of the course of the computer science. So we have course table, there are different courses, right? There are different courses like DBMS, some other courses. It will just filter the courses from the computer science and then perform the join. First filtering it should perform and then joining, or first joining and filtering, that kind of thing. Execution plan, like it will generate the execution plan based on the optimized query. So first filtering and then joining, that kind of thing, that will give us, that will take less time. So it will generate the execution plan. The execution plan will generate how to execute the query, which step has to perform first, that will be generated by the execution plan. And then evaluation engine just evaluates our query and fetches the result of the query and displays and gives it back to the us. So these are the steps. So first we'll write the query. That query is checked by the parser and translator, and then the optimization of the query will be done. It will generate the execution plan of the optimized query. Which thing has to do first? That kind of thing in our query. It will generate execution plan for that query, and evaluate engine will evaluate the query, fetches the data, the required, the whatever the query we have written, that data will be fetched and that will be given for that query as output. Okay, clear? How the query processor? Okay, that just whatever this is here mentioned, I will read. Alternate ways of evaluating a given query. Query processor will just write down the alternate ways of evaluating a given query. It will write the equivalent expressions of the whatever the query we have written. It will just find the different algorithms for each operation. So cost difference between good and bad way of evaluating query can be enormous. Need to estimate the cost of operations, which operation has to be performed, and which operation will take time, and how much data it will fetch. That kind of things will be estimated by the query processor. Depends critically on the statistical information about the relations which the database must maintain. Need to estimate the statistics for intermediate result to compute the cost of complex expression. So just it will rewrite our query and evaluate the different queries. It will see which is most effective based on the which one is most effective, and it will give the execution, like it will pass that the optimized query to the processor, to the execution plan. Okay, only these things of the query processor. Then you have storage management, query processing, and transaction manager in the database engine. So transaction management, what it does, what if the system fails, what if more than one user is concurrently updating that same data. Okay, if there are more than one user are concurrently updating the same data, then how that is handled in the case of DBMS, that is done by using the transaction management. So a transaction is nothing but a collection of operations that performs a single logical function in a database application. So just let us say we are updating the balance of an account, that is also a transaction. We are updating the name of account, we are updating the name of something, that is also a transaction. Whatever the change, the single operation we perform, single logical operation that we perform on the database, that is called transaction. So transaction management as transaction management component that ensures the database remain in consistent state despite the system failures. Even the system fails, okay, you are performing in a transaction, in between the transaction if some power failures or some system crashes, some fire accident or something has happened, okay, the transaction management component ensures the database remains in consistent. That means, okay, in between, okay, you are like the transaction is nothing but you are transferring account A has 2000 and account B has 500, let us say. Now let us say we are performing transaction 500, like 500 is debiting from account A to account B, so 1500, like 500 is debiting, we are debiting like we are debiting we are what, so account B should have 1000, no, but in between, before performing this transaction, before updating the value of B, before updating the value of B, like 500 has debited from account B, but it has not credited to account. 500 has debited from account A, but it has not credited to account B. Some failure has happened. Then how transaction management component will do? It will just ensure us like it will just make it will restore our data, our database to the consistent state as if transaction has not happened, as if this updation has not happened. See, it will how it does, it will, you will see in the coming weeks, it will just see the log information, log file, and it will see what operation we have done to the database, okay, before committing, before doing, like after doing any transaction we will commit the transaction, the committed transaction only will be updated to the database. So this operation has not finished. After performing the complete operation, only commit will happen. No, this operation has not finished, so commit has not happened. So before commit, what is the state of the database? That last committed, the database will be restored to the last committed state, the previous committed state. So the value of A and the value of B will, A will be 2000, the value of B will be 500. So this is how transaction management component deals. So it ensures that the database will remain the consistent state despite the system failure. Even if the system failure or something has happened, it will make sure our database will remain in the consistent state. One of the example we have seen here is like from A to B, we are crediting the amount of 500. From A, we are debiting 500 and crediting it to B. But if some failure has happened in between, then the transaction has not finished completely, the commit has not happened. So what the database will do, it will restore our data to the previous committed state. The previous committed state is this one. This one. Yeah, the
Ma'am,
transaction
how it
management.
decide that how it confirm that transaction happened successfully?
The commit operation. So if something, some operation for every transaction, we'll start the there is something called in the log, we will maintain the log of the transaction. Before starting the transaction, we'll write T start, the transaction has started, and whatever the operations we are performing, we will perform. And after finishing the transaction, commit, we'll do the commit. If we commit that particular transaction, then only if the transaction is committed, then only that information will be updated in the database. Okay, that information won't be updated in the database until the commit has happened. If the transaction has finished successfully, then only we'll do the commit. After committing then only the result will be updated in the database. Before the commit operation, that won't be updated. Here, as the transaction has not finished, the commit operation won't happen, so the database will be restored to the last committed state. That means the previous committed state, where the values of A and B will be 500. So based on that will be everything, the history that will be maintained in the log, the transaction log. By seeing the transaction log, the transaction management, that's how the database will be restored to the consistent state.
So for that, A have to establish connection with B for confirmation, right?
No, what connection? We will connect to the database. In the database, there are accounts A and B. Okay, there is something called log, transaction log. So whatever operation we do, that will be logged in the transaction log. So based on this log only, to which, okay, if some failure has happened, based on the transaction log, it will decide to which state the database has to be restored. So which database has to be restored based on the transaction log, it will decide. Okay, it will. Okay, these things you no need to worry about now. Just understand the transaction management component will ensure the database remains consistent. So this kind of, so the 50 the okay, if you see, if there are 100 accounts in a bank, the sum of the balances should be same. Should be like if the balance is something like 10 lakhs, the sum of the accounts balance is 10 lakhs. Whatever the transaction you perform within this account, the amount should be 10 lakhs only. 10 lakhs only. If some mistake has happened, here something, it has debited, it has not credited. So now what will be our balance? It will be 500 less than that, whatever the things we are seeing. That is called inconsistent state. That should not happen. So our transaction management component ensures to be consistent state. Here we are not doing it manually, no, so that is done automatically by, that things are taken care by transaction manager. Okay, so no need to worry if some transaction fails or something about the inconsistency of the database. We like, no need to worry about the inconsistent state of the database, because the transaction manager will will automatically restores our data to the consistent state. So there is something called concurrency control manager, controls the interaction among the concurrent transactions to ensure the consistency of the database. So let us say the same, we are performing the operation on the same, we are accessing the same data element concurrently. Okay, then it may lead to the inconsistent state of the database. So let us say here we are debiting, and some other from some other account, from some other account C, some 800 is credited into account A. So A is debiting, like we are transferring from A to B, and C is transferring to A. So we are operating on the same data item, same account A. So even if we are performing the multiple operations on the same same data element, that should not lead to the that should not make our database inconsistent. So the concurrency control manager does this, controls the interaction among the concurrent transaction. So here we are doing two transaction concurrently, from A to B and from C to A. This is doing the things simultaneously. So this, at the same time, if we do, the concurrency control manager controls this kind of interaction, controls the interaction among the concurrent transaction to ensure the consistency of the database. In order to ensure the consistency of the database, concurrency manager uh, works. Okay, database system internals, it is not required. Okay, just about the database engine, you need to know about the processing thing, query processing, storage manager, and the transaction management. About these things only, these things internal, database system internals, it is not required. Okay, any other doubts you have from all these things? That's all, no, that's all in week 5, in week 1, lecture 5, week 1.
Ma'am, what are the things that we should focus in week one? More focus in week one.
Okay,
The
the
key out.
whatever I have explained, so there is some table, no, I will tell. Okay, this table, not here, lecture 1.2, no need to worry, but that is already there. This table, what is the what is the difference between file handling via Python and EBMS comparison, this one. So in this table you need to this one you need to know thoroughly. And from this lecture, like if you see this point, that are points itself are self-explanatory. Okay, these points. And here, in here, you need to know about physical, this diagram, levels of abstraction, A logical schema instance, yeah, this just physical data independence, that thing. Data models are not required. Okay. See the table, whatever table we have seen previously, the comparison between file handling via Python and database, DBMS, and then the levels of abstraction, physical data independence, what is logical schema, what is physical schema, what is instance, only that definitions. And then that is from lecture 1.4, that is from lecture 1.4. DDL and DML also. What is DDL and what is DML? That thing you have to see.
So
Then
we are
here,
going to study these topics in upcoming weeks, like in this course.
yes, you will see. Logical design, physical design, you will see. You will see in the upcoming things. Uh, and here, just this nothing. Database engine, storage manager, query processing, and transaction manager. Only these things. First, comparison, file handling, comparison of file handling and database. That's one. Python, files, and database, and then this one is table, and then you have levels of abstraction, that is from lecture 3, and then logical schema, physical schema, logical design, physical data independence, that definitions, uh, and transaction manager, DDL, DML, that thing. Transaction manager, database engine, that all the things, storage manager, query processing, only these things you need to worry. About logical design, physical design, you will see in the coming weeks. These things won't happen again. Levels of abstraction, comparison, the thing you won't see again. The query, this database engine also you won't see again. Only logical design, how you would do, how you design the database, that you will see in the coming weeks.
Ma'am, can you go to the slide where the logical schema and the physical schema is written?
Yeah, yes.
Yes. Uh, got it, ma'am. If possible, can you throw some quick light on this two, logical schema and physical schema? Like,
So logical schema that describes the logical structure of the database. That thing we have already seen, no? What are we going to store in the database? What tables? In the table itself, what attributes we are going to see? So in the example here we discussed is railway system. Suppose we have to maintain the database for railway system. What all tables we have to see? We have to store in the database. So trains tables we have to store in the database, stations table, and some what ticket booking table, and about the like staff and the registrations, like whatever the user will register, login, no, that kind of thing. Everything you have to, all the things which should be kept in the database. In the table itself, what all attributes you have to store. So suppose for train, what information you have to store? Train number and train name, and also which from which station, which all station the train drops, and which time it reaches that particular station. All the things about the train. For the station also, what all trains will come to that station. Okay, that kind of thing. At what time that train will arrive, that kind of information.
it is
And
like,
for the
sorry, it is like column names.
column. See, here example here is customer schema, account schema. In the customer, like we have decided to store customer information and account information in our database. In the customer table, what all attributes we are going to store? Name, customer ID, account number. That are column names. Column names are called attributes. Okay, what all attributes we are going to store in the database, and what table we have to store in the database, what tables or what relations. So tables are called relations, and attributes are called like column names are called attributes. Okay, so what relations and what attributes in a relation, that thing will come in the logical schema. So what information are we going to keep in the database? How it is stored, that is physical. Like how like whether we are going to store the information in arrays or linked list or some b trees, b place trees, or in where we are going to store, in which data structure, that will come in the physical design. The physical layout of the database will be coming the physical schema.
Didn't get the physical schema what you just said. All the things. Wait,
So we see logical schema describes just what we are going to store. Okay,
mhm.
but in the case of in memory, how we are going to store this account table or customer table, how
Is it
the
like a
information is
hard drive
stored?
or something?
Yeah, the information will be stored in some memory, like in some disk or some other data structure, data element only. Okay, finally it should be stored in some data element. How it is going to store, how the data is organized in the disk or something in the memory block, that will be come in the physical level. Okay.
Understood, ma'am. Thanks.
Yeah.
Ma'am, excuse me.
Yeah, yes.
Ma'am, can you go to the database design slide?
Yeah.
Not this one, the engine one. The query part that you had
Database
explained.
engine. Yeah, yes.
Yeah, sorry. Ma'am, here can you briefly again explain about the query processing ones?
Yeah,
Yes,
sure.
ma'am. I can.
Please.
So query processor, in the query processing, like first we will just give some query. So this is SQL query. Select name from instructor, comma course where course name equal to some computer science. So just we are just getting the instructor name who teaches computer science or something. Here let us say course comma teaches something. There is some table. Okay, this is some query we are giving to we are writing. What how the queries will be processed by the database engine is, like it takes the query and the parser and translator will check whether there are syntactical errors in the query. Let us say we are just checking computer science. No, computer science is a string. That string should be enclosed in single quotes. We are not giving single quotes, then that will give some error, that will say incorrect select query for us. So that kind of thing, it will be taken care by the parser and translator. It will just check for the syntactical error of the query. Okay, and the
Yes,
query,
ma'am.
yeah, the query will be, now if the query is correct syntactically, the query will be rewritten such that, okay, see here there are two operations here, like joining of the tables and selection, like filtering. So first we can filter the what we are filter we can filter the particular rows, like we can filter only the computer science rows and join the two tables. Or before joining, we can, before filtering we can join the two tables, after joining we can filter the computer science rows. So that kind of thing, the query will be rewritten and it will be checked for the efficient query. Okay, so what query will do,
Ma'am,
it will write.
ma'am, here, what do you mean when you say the query will be rewritten?
Yeah, it will be the query processing internally. It will just analyze whatever the query we have written, and it will check for the
So,
optimized query. Yeah.
so here we're calling it as a rewritten query because first the syntactical error is being checked if there is some or not, and then the main query that we had put forward will be checked.
Yeah, whatever the query we have written, if does not have any syntactical error, the query processor will continue its execution, like will do further steps in the query processor. Processing further steps will happen. What it will do is, it will check for the alternate ways of evaluating a given query, write the equivalent expressions, different algorithm for each operations. It will just try the query in different ways. Okay, whatever the query that whatever the query whatever the efficient query, the query we give, it will check for the efficient way of executing that. Okay, after finding the efficient way, like what our query will do, query will just fetch the data from. Okay, why we are writing the query? In order to get the data. So what the query processor will do, it will get our data in an efficient way. Okay, we are writing the query in order to get the data from the database. In order to retrieve the data from the database, we are writing the query. In order to update something in the database, we are writing a query. Okay, in order to get the data, what it will do, what is a efficient way of getting that the data without involving most operations or less time consuming, or that thing will be the query processing will do. It will do the query, whatever query we have given, it will just check for the alternate ways of evaluating the query and fetches and what finds out the efficient query way of doing that, efficient way of fetching the data from the query. And it will just give the execution plan, like how to execute the query, like which operation has to perform first, whether filtering has to perform first or joining of the tables and then getting the resultant attribute of the table should happen. That kind of step by step way of executing the query, that will be given, that is execution plan, that will be generated. And whatever the execution plan that given, that will be evaluated by the evaluation engine, and it will just fetches the data from the database, evaluates the query and give the data, and the given data will be given as the output.
All right, understood. Thank you.
Ma'am, in physical level, when you are talking about how you are going to store data, so it's about like in arrays or list or dictionary, this kind of thing.
In what, see, it is just we are going to store data in memory, right? In memory, the memory, like in the disk, finally we will store in the data in the disk. But how the data is organized, how we have to organize the data, that will come in the physical level.
So data structures like,
Yeah, data structures, all the files, everything, memory blocks, everything, disk, everything, that thing will be seen in the physical level only.
so in reality, they are not like designed in row and column like table wise, no.
No, they are not the in the finally just for understanding, that is in the logical level they are as tables, but finally they are going to store in some file only. The database will take care of how fetching the data from that files and everything. Finally, we have to store our data in some file like disk only, memory only. Okay, the tables are just for our visualization purpose. The data won't be stored in the table. Data will be stored in the memory. Like for int, for char, some particular byte of memory will be there. But that kind of thing. Okay. But they are just for the tables and everything is for understanding and for understanding purpose.
But how can there can be two ways of evaluating the same query?
Yeah, I have seen. No, so you have some subquery. Okay, whatever the query, like you have written a subquery. Subquery means query in a query. That kind of thing can be done using joins also, by joining the tables also. That, yeah, whatever the query you have written, that if the joining of the tables consumes less time, then join it will do the joining first and then it will give the result. Or okay, uh, that things you will come to know in week 2 and weekly when you write the queries. But okay, joining of the tables means you are what, merging the two tables information. There are different kinds of join, cross join, natural join, all the things. But uh, if you join the two tables, then the data will be more. So this data and this data, both tables data will be merged. No? The data will be more on the day, on the more data. If you apply filter, like if you wanted to select some computer science or some particular instructor or some particular department or some particular salary or something, some that is filtering. Just if you wanted to filter the rows of your table, then you can filter first. Filter first means, okay, there are like 10 rows here and 10 rows here. If you join, if you do cross join, then it will give how many rows total. So 10 into 10 rows, it will give 100 rows. On the 100 rows, you have to apply filter. Before applying, okay, this is one way of doing. After applying filter, there will be 20 rows, let us say. Okay, this is one way of doing the query. The other way is like you have 10 rows here and you have 10 rows here. After filtering, you are like you have to filter the computer science department rows. Okay, let us say there are only 2 rows of the computer science. Then you will just You have 2 rows here and you have 10 rows here. So joining will give 20 rows. And the output, the joining operation, now you have to perform only with after filtering. The number of rows is less. That will take less time. So a query can be executed in different ways. Okay, first, if you have written subquery, the subquery can be done by using join operation also. So it will evaluate which one will take less time and which is efficient way of retrieving our data. So based on that, it will give the execution plan of that how to execute the query.
So when we say that there is relation between tables, like one or two tables,
When we say,
there is a relation between tables.
yeah, if the relation will be there now between the table, which relation you are telling? What kind of relation?
No, no, last TA session, TA was explaining like that.
Relation. Okay, relations between table. That means, so instructor table, like instructor will have department name, so each instructor will be working in some particular table. So for the department also, okay, there are two tables, let us say instructor and department. So instructor table is like in the instructor table we will store the department information also, that kind of thing. Or the better example, let us say, uh, what is the relationship between the student and instructor? So, or a student and the course, student takes some course, that is the relationship between the student and course. Or employee and manager, manager manages the employee, that is the relationship between the manager and employee. So that kind of relationship you are talking, no? That is what you are asking.
Yes.
Yeah, that comes in the logical schema. So what are tables you are going to store and what is the relationship between the table? So let us say the some university or something. So instructor teaches a course and students takes a course, that is the relationship between the instructor and course, and instructor and the student, and student and the course. Okay, that will
So
come
if
in the
there is
logical.
any common attributes in both table, then they are related to each other.
Not like that. There cannot be any common attribute also between the table. So if there is common attribute, yeah, that cannot be always true. If there is some common attribute, then they are related. Yeah,
So we are going to study this topic in upcoming week now.
yeah, you will study in
Okay.
before. So whatever information instructor manager, like employee manager, employee manager manages employees. Student takes course, instructor teaches course, all these things. Teachers is a relationship, takes is a relationship, managers is a relationship between employee and manager. Other example also you can see, like from accounts, like customer takes loans or bank offers loans. Offers is relationship between bank and customer, and customer takes avails loan. So loan and customer have avail relationship. Okay, that for relationship also sometimes we maintain table. Okay, in the relationship also we'll make a table which customer has took which loan, what is the loan ID, come some kind of thing that will come in the logical design.
Excuse me, ma'am.
Yeah.
Are we done with the today's session, or is
Yes.
there
Yeah.
any?
No, nothing. Yeah.
Thanks, ma'am.
Yeah.
Ma'am,
Thanks.
I have a query over here.
Yeah.
For example, if we are talking about, like, we have two tables,
Mm.
and in one of the table there is a particular filter which we have to apply multiple times. Like, for example, computer science department, we don't have a separate sub data for it, but we keep referring that data quite often. So just by using the select command, is it possible to create a sub table out of the main table? Then querying on that sub table would be faster, right?
Yes. Yeah. Yeah.
So we can do that.
Yeah. You can do that. While querying, also you can write some optimized query.
Yeah, I understood that by using query we can again and again retrieve the same sub table by applying some filters. But if we want to store that particular subtable permanently as a data,
You can
in that
store it
case,
also, but there are also some query for that.
okay, okay, ma'am.
Okay, that's all. Yeah, if you have any doubt, you can ask. If not, we can just close the session.
Ma'am, I have a doubt in week two assignment of coding.
What a doubt? What doubt?
Ma'am, not a doubt, but just a clarification that in test case, the score will be 100 out of 100. Then it will
Hmm.
be means that the
All
query
the
is
cases are passed.
doing.
Yeah.
Okay, thanks, ma'am.
Yeah, so you will get a correct select query and you will get marks 100 out of 100. Yeah.
Okay, ma'am. Thanks.
Okay, if you don't have any doubts, I will just stop the session. Thanks all for joining.